So, dear participants, the topic for my session today is Industry 4.0 connecting the metaverse. So, already you have might have had some introduction to metaverse. Already you are familiar with metaverse. So, in this presentation, we will be covering majorly Industry 4.0. So, I will be giving you introduction to Industry 4.0 with a brief history background, how this Industry 4.0, how we came to Industry 4.0, then the technologies which are driving Industry 4.0, and in the next part of the presentation, I will be talking about the industrial metaverse, the topic for your FDP, that is marketing in the metaverse era. Here today, I will be talking about metaverse in perspective to Industry 4.0. That means how this metaverse will work in the industry. So, a little bit about that. So, dear participants, if we talk about the history of industrial revolution came into account when the first industry came, that is in the years, see the exact time period in history that is not known, but we can say in the 1760s to 1840 the first industrial revolution has been recorded, followed by the second revolution which started in 1870s to 1940s, then third industrial revolution, and now we are in the fourth industrial revolution. Now, if you see here in this figure, you can very well see that the first industrial revolution, the symbol here shown is mechanical weaving loom, introduction of mechanical production assets based on water and steam power. Then the second industrial revolution, introduction of moving assembly line at Ford Motors. Third industrial revolution is known as first programmable logic controllers. They were introduced here. And today we are in the fourth industrial revolution and going towards the metaverse. So, a brief history about Industrial Revolution 1. See, can you imagine a time period when there was no industry? No industry here actually means when there were no machines which were used. That means all the work which you were doing in industries or at home or anywhere, we were doing it with our own hands. So this industrial revolution actually came in when with the introduction of steam engines. So the British people during that time, you can say Britain or United Kingdom, they were the successors in Industrial Revolution 1. They were the pioneers in bringing this Industrial Revolution. That is why during that period they were very rich, the European countries. Actually, before that, the manual production was taking place. So they introduced this steam engine there. Steam engine means the steams they introduced this steam engine. So all of you are aware of this steam engine. Basically, James Watt person was a person who introduced this steam engine. That means now the steam was used for doing work. That means now you are not doing the work manually, but a machine has been introduced which can do your work. So can you imagine a work which was taking several days? Now that work could be done in few hours. Small menial works, for example, the flour mills, through which you convert wheat into flour, the paper mills, the cotton mills, the iron works, distilleries, the water works. Now, all these work which could be done in which took few days, now it could be done in few hours by the introduction of this steam engine. Not only this, before that, all the transportation that used to be either manually or through with the help of animals. But with the introduction or the concept of steam, they introduced the steam powered locomotives. So, steam powered locomotive means the transportation from one place to another, whether the passengers or the goods. This transportation also became easier and faster. Similarly, they use these steam powered engines in case of boats also. So instead of manual boats, now they had steam powered boats, or you can say ships. So that is what actually happened during those days. These British, Britain, when they were having this East India Company, actually, when they were ruling on our country. So what they used to do, they used to take the raw material from us, the cotton and other raw material, cloth and all cotton from us, and they used their own machinery for weaving that cotton into cloth, and then they used to sell that cloth at an expensive price. So that is why during that time period they were very these were the rich countries because they had the power of machinery, they had the power of technology. So dear participants, it is very important that you have the power of technology so that you are able to go along with the other countries. So this industrial revolution one continued for many years, as you can see the time period. So many countries, many people, they had their own industries. They used the steam engine for work, doing work. After that, this was followed by Industrial Revolution 2.0. What is the history behind Industrial Revolution 2.0? This person, Henry Ford, you are aware of this owner of Ford companies. So this person, he introduced a new idea of mass production, or you can also call it as conveyor belts. Now imagine before this Industrial Revolution 2.0, all the work which was being done, this was done by using machine. That means a machine is there, you take the work, do the work on the machine, then you take it to the another machine, third machine, likewise. So though there were machines, but the work was still slower because you have to manually take the work from one place to another, and it was not, no automation was there in the work. So this person, Henry Ford, he introduced this conveyor belt idea and mass production. How it took place, actually, if you see this figure, he once got a chance to go to a butcher house. Butcher house means where they produce the meat from the animals. So there he observed that on in this pigs were hung from one side, and this pig was moving on a conveyor belt. There was a belt or a table which was moving, a belt was moving. So this pig was moving from one place to another. While this pig was moving, each person, some persons were stationed during the on this table at a particular gap. And while the pig was moving, each person was doing his own work, and they were cutting a piece of that pig, and meat was produced. So he observed, Henry Ford observed that while moving on this conveyor belt, the meat which is being produced or the parts which are being cut, it is much faster than if one person is standing at one place, he is cutting it or he is cutting some part, then taking it to other place. So from here, this idea came to his mind, and he was manufacturing these cars, Ford motors. So he introduced this concept of these conveyor belts in his industry, and now he was able to do work faster, and which we call as, in mechanical engineering we call it as mass production was possible. Now I have taken this photograph, a very old photograph. If you see here, this is one part of the automobile, that is a flywheel. So this flywheel, it will start moving on this conveyor belt, and from here each person standing in this line, they will keep on adding their parts. So this person is putting one bolt, other person is putting one nut, and this person is putting some other part. So by the end of the line, while moving on the conveyor belt, the entire work will be finished for this flywheel. So this concept of conveyor belt, or which we also call as, due to this conveyor belt, the mass production was possible. This significantly made the work, if you see these two words, faster, and also the cost involved was lowered. So this Industrial Revolution too, so technology has changed the world in many ways during this Industrial Revolution too. And people's lives were not regulated by clock, they were regulated by the clock but not by the sun. So a lot of new introductions came during this Industrial Revolution too. So these were, railroads were there. Then steel production, large scale iron and steel production was very important. We know that in each and every part, steel or iron is the most commonly used metal. Then there was widespread use of machinery in manufacturing, greatly increased use of steam power. Then telegraph came, the use of petroleum and other products, and of course a very important another thing, that is electrification. Electricity was there. So these were the major parts of Industrial Revolution 2. Until now, it is considered that Industrial Revolution 2 is the most prominent and most revolutionized among other revolutions. Now conveyor belt thing had come. From the conveyor belt, some automation, they had already started using conveyor belts. So based upon that, the partial automation also started coming in the industrial revolution 3.0. So if the major two things were memory programmable controls, that means you give some commands and the machine can do some operations. And of course, another very important revolutionary thing which came in industrial revolution 3 was the computers. Now the introduction of these technologies, by these technologies we were able to automate an entire production process. Now initially there were only conveyor belts. Now automatic things, automation of industries started coming place during industrial revolution 3.0. So computers and memory programmable controls, these were the two major things of the industrial revolution. And of course, the third revolution also brought the rise of electronics, telecommunications, and computers. Two other things which gained a lot of momentum was the entrance to the space expeditions, the research, and as well as the biotechnologies. And PLCs and robots, but they were the major things which came during the industrial revolution 3. And in the second half of the 20th century, we see the emergence of yet another source of untapped energy, that was nuclear energy. In the 20th century, another very important thing came, that was the nuclear energy, third revolution. Now, fourth revolution. Dear participants, we all are now currently implementing the fourth industrial revolution. This is characterized by the application of information and communication technologies to industry, and we call it as Industry 4.0. At many places, you will see I 4.0, Industry 4.0, or Industrial Revolution 4.0. So, after the third revolution, we came to this fourth industrial revolution, which is taking place now. And I will also show you in the further files, PPTs, how this Industry 4.0 will now be taken place by the metaverse. So let us first of all understand this Industrial Revolution 4.0. Now the production systems that we already had, computer technology, now they started expanded using network connection and a digital twin. This is a very important point, digital twin. I will show you one or two videos and elaborate more on the digital twin, because this is very important aspect in your industrial metaverse. So digital twin on the internet, so as to speak. So these allow communication with other facilities and the output of information about themselves, and we call it as the next step in the production automation. Now, what are the various technologies? There are a number of technologies. Some of the important technologies which are driving industrial revolution in this fourth industrial revolution are the big data analytics, autonomous robots, artificial intelligence, horizontal and vertical integration, industrial Internet of Things, cybersecurity, additive manufacturing, and augmented reality. I have listed some of the technologies which are driving this Industry 4.0. Already, you must have heard about these few of these augmented reality and virtual reality. So, I will not go much in detail, just a brief about these technologies which are driving the Industry 4.0. Now, dear participants, most of you are from engineering colleges or from polytechnics. So why there is requirement of Industry 4.0 or knowing about the technologies which are driving Industry 4.0? See, by the time your students will come out from their diploma, when they will finish their diploma or when they will finish their degree, definitely they should know these technologies, which are the prevalent technologies. As I showed you in the previous slides, when the industrial revolution came, so if some technology has been devised, if you do not adopt that new technology, if any country or if any region do not adopt that technology, they will be left behind. So it is very important, especially in these days when we know the technology is becoming obsolete so soon, and it has been replaced by a new technology. So, dear participants, it is very, very important that your students, along with the curriculum which they are studying, they should know about these technologies. They should, for this, what you can do, you should give some small projects, small work to your students, so that they can do some work in their in these technologies. So here I will take a few I will like to take your feedback from the participants, if you are aware of, or if any of you have done some work in these technologies, or if you have given some assignment or some project or guided some project to your students in any of these technologies which I have listed here. So the purpose of showing you these technologies is that definitely you should ask. I will switch off my video to save the bandwidth. Yes. So so the purpose of this showing this technology is that you in your engineering college, or as your teacher in any field, see, like ma'am is saying, Nitya ma'am is saying, they have done some projects in artificial intelligence. So that is good. In computers you can do some projects in big data analytics, cyber security, something in cyber security, artificial intelligence. Then electronic people, they can go for internet of things, IoTs, they can make some sensors, some applications using the sensors. Then in augmented reality, so a lot of students are already doing in mechanical. If you are working, you can do something related to autonomous robots and something related to additive manufacturing. So these are the upcoming technologies which are now being used. So you need to uh, ask your students to work in some of these technologies. So I will just tell you briefly about these technologies. Basically, Internet of Things, IoT, this describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So basically, let me give you one example. Suppose we are you are using this IoT for farming. So this, if a sensor is there inside a farming place, sensors will be embedded, IoT sensors will be embedded in the farming place. So otherwise, what the farmer do, he goes to his farming land, and he checks with his analyze the soil and checks, yes, there is a requirement of water. So he will switch on the water pump, and then he will water the plants. Then again the farmer will go in the fields and check whether the field now water has been given. Again he will go back and switch off the pump. Similar procedure he will follow when he want to give fertilizers, or if he want to give some manure or fertilizers to the to his crops. But if you have used IoT, Internet of Things, and there are sensors which are embedded in the soil, the sensor already has some previous data. The sensor will make a decision and check the quality of the soil, and it will give its data to a central processor. That processor, which has the previous data also, it will correlate that data, and automatically that sensor will be it will make a decision using artificial intelligence. Okay, yes, now there is a requirement of water, so that will be further connected to another button, which will automatically switch on the water pump. Now the fields will automatically be watered by using that through that water pump. Again there is another sensor inside the soil, which will see that yes, now enough moisture, enough water has been given to the soil. Again it will give its feedback to back, and using that feedback, again the water pump will be switched off. So this is how the Internet of Things will work. So this is how, by using sensors, you can use this technology. All of us are familiar with artificial intelligence. Everywhere around us, we are all covered with this artificial intelligence. How it works, it recognizes complex patterns, it processes the informations, from there it draws the conclusion, and it makes some recommendations. Means by using your own data, it is processing it, and it is deducing some or drawing out some conclusions, and it is making some uh, decisions or giving you some recommendations. So every day we are part of artificial intelligence series. Alexa, it automatically, if you tell Alexa, I want to play these songs, it automatically plays songs. Then in medical field, disease mapping and prediction tools. Then in manufacturing, also in drone robots, the drones, they also work on artificial intelligence. And when some drone is going, some obstacle come, it diverts and it changes its routes. So healthcare treatment recommendations which you get on your smart watches, that are also based on artificial intelligence. You must have wondered, all of us are using emails, Gmail, let us say, then they automatically some of the mails goes in the spam filter. That means someone is there apart from you. If I am using my email account, and some of the these mails are going into the spam filter, who is doing that, how it is making that decision, because these mails have to go in the spam filter. This is all the background of all this is the artificial intelligence. Social media monitoring tools for dangerous content or false, then songs, the TV recommendations from Spotify or from Netflix, all these thing artificial intelligence is already working around us. So virtual reality, some of the speakers might have already told you about virtual reality means you wear some you wear some glasses or some gloves, and you virtually go in a separate space and you have a new simulated artificial environment. So this virtual reality, I will show you how we are using virtual and augmented reality in your metaverse, in industrial metaverse. So already some speakers might have already told you about this virtual reality. The base of this virtual reality, how it started, was from simplest example is your 3D movies. The three-dimensional movie, it shows you that it gives you a feel that you are in that particular place. You are experiencing that a leaf is going or something is coming in your eyes, you feel. So all this is giving you an idea of virtual reality. But this is just a simple example. But all of you might have seen these virtual reality glasses. By wearing these glasses, you can go in space, you can go anywhere else. Another very important tool of this industry 4.0 is augmented reality. Means without actually bringing that physical object, we can visualize it in our space only. So, if a very simple example to make you understand is your Google Lens when you use your phones, or suppose this is your room, and by using augmented reality, you can see how this sofa set will look in that particular space. Your makeup people, they are using augmented reality. Many of the games, the Pokemon Go game was there, that was also based on augmented reality. And now a number of applications are made by using augmented reality. So, another very important aspect in manufacturing, since we are talking about industry and industrial revolution, so manufacturing is another very important aspect. Now, this additive manufacturing, when this came, this was again a revolutionary addition, because before that, the most of the manufacturing which we were using, that was actually known as subtractive manufacturing. Subtractive means we were, if you know, that we were cutting the material and obtaining that particular shape. We were removing the material and obtaining that shape. Then this new concept came, additive manufacturing, which is other name for this is the 3D printing or additive manufacturing or rapid prototyping also it is called. So in this additive manufacturing, like you have a 2D printer, we have a 3D printer. In industry 4.0, this additive manufacturing is a very important aspect. Here, why this is very important, because now you can make customized products. See, in second industrial revolution, we talked about mass production, but a short coming of mass production is that only one type of shape that can be produced faster. But when you want some customized products, especially when we talk about the products which we use in our body, bioplants and all, then we require this additive manufacturing. So a brief about what is actually additive manufacturing. It is very simple to understand. And now these days, many of the schools, they also have some 3D printers in their schools. So, in engineering colleges also and in polytechnics, I would suggest that you have these small additive manufacturing, these 3D printers, so that the students can understand and they can actually work with this and actually produce some 3D printed products. So, this basic idea behind 3D printing or additive manufacturing is that Simply you have to make a drawing. You first make a 2D drawing. I have taken this example from a book. Suppose you want to manufacture this cup. You want to manufacture this cup by using 3D printing, or which we call as additive manufacturing. So what you have to do, you just have to, starting from step 1, you just have to make a drawing like you do AutoCAD and all. You make a 2D drawing of the cup, and you convert it into a 3D drawing. So this is a simple drawing rendering. After rendering, so this is a drawing we have made for this cup. Now take that drawing and we convert that into an format. Like you have different formats. So here we have the STL converter format. So we convert this into STL, and this second drawing is and we feed this STL to the machine. So what only work you have to do in this is you just have to make a drawing, 2D drawing, and convert it into 3D. So this 3D drawing is converted into STL by using STL convert, and you just feed it with the help of a pen drive to the 3D printer. So if it is a metal printer, here at NITTTR we have a metal printer also. So if it is a metal printer, let us suppose you just have to feed the metal, and you have to give this command to this. This will automatically take the drawing from this, and it will automatically prepare its own coordinates. See, in the step 4, it has made the coordinates how the printing will be done, and then the printing will start. And after the printing has been finished, after step 6, you remove the cup. It will be here on the plate, and the 3D product has been produced. And lastly, if you want to do some post processing like some heat treatment and all, otherwise some paint and something like that, otherwise your product is ready to be used. So what is the major advantage of additive manufacturing? The final shape which you want, you just feed that final shape into the machine, and the same product will be manufactured automatically by using this machine. So dear participant, it is very simple, and I would suggest that in your institutes you should have one or two these 3D printers, so that the students can have an idea how to 3D print the products. So I have taken these photographs of our institute from our department. Metal 3D printer. We have a metal 3D printer also. So stainless steel, titanium, and other metals can be printed using this 3D printer. And we have a rapid ABS polymer based printer also. So these are the two printers. And this is one 3D printed samples of one of my students who actually 3D printed it by using steel, 174 PS steel. So these were the different shapes which we wanted for our testing purposes, tensile pieces, simple pieces. So we 3D printed it on the machine. If you see here, this is the base plate. The base plate, on the base plate, the product is printed, and then you remove the product from the base plate. So this is the actual, whatever command you give, the actual shape will be produced by using this 3D printing. Now, what are the various applications where you can use this 3D printing? The major applications is in our body parts, which we call as bioimplants. Whenever there is some surgery, some of these days it is very common. Many of us are getting our knees placed, knee surgeries are there, hip and knee implants are there. Or if somebody has some accident, so they put some rods inside your body. So sometimes some specific shape is required for a particular part. So that can be done. Patient specific shapes can be produced by using this 3D printing or additive manufacturing. So the specific shape or specific that can be done by using this 3D printing. So bioimplants can be done these days. The dental implants, they are also done by 3D printing. The dental implants which we have in our when we remove our teeth. A very another important application, a future application of 3D printing is your bioprinters. Have you heard about these bioprinters? So we have one bioprinter at our institute. What is the purpose of this bioprinter? See, in the previous slide, we only talked about these metal plants, which are required to be replaced. But now you can also produce the tissues. You can also replace the tissues. So have you heard about these stem cells? Now when a baby is born, they keep the stem cells of that newborn baby. The purpose of that is that in future, if he has some ailment or some disease, they will use that cell from there, and they will reproduce the cells, and they can heal many disease. You must have heard about this. So this is a new latest technology which is being used, that is biotechnology, which we call as the tissue engineering applications of 3D printing. Now what they do, by they remove the cell from your body. This is a cell isolation. I will just tell you briefly. A lot of research is now going in this tissue engineering, and then they will produce that cell culture in the lab. Using your cell, they will grow more cells outside your body, and then they will build, in order to give it strength, a scaffold is prepared. This 3D printed, a mesh type of thing is prepared using these 3D printers, bioprinters. So that scaffold on the, because we require, along with the cell, we require some strength also. So using this scaffold which has been 3D printed, over this, these cells will be grown, and the entire tissue is grown outside. In order to give it mechanical strength, we have this scaffold which has been 3D printed, and this tissue or the cell is grown outside. So this entire tissue can now be implanted in your body, and it can be removed or replaced with a, bad tissue, or the tissue which is not working properly. So this is how the new technology, biotechnology, is working. Now we are replacing the tissues also inside the human body, using this by growing these cells outside the body. So this is one of the latest which is taking place using 3D printing in your biotechnology. So, dear participants, all of you are aware of these robots, these drones which we have. Drone technology is also taking place. So, try to give some small assignments to students so that they can build their own robots, small drones, and they have some know-how in that. So, a robot is a machine, especially one programmable by a computer. So, it is capable of carrying out complex series of actions automatically. Robotic ref, robot, Robotics refers to the design, manufacture, and use of robots for personal and commercial use. So we will, the time is not far when we will have robot assistants in every home. Already many places for old age homes, they are already started using robot assistants who are doing some menial work, small works, household works also. So it is widely used in manufacturing, design, and other places for personal and commercial use. So before we go to the industrial metaverse, I now we will go to the next section of this presentation, that is industrial metaverse. So any questions from anybody? Yes, any participant, if you have any query or anything you want to add. So we have already covered about the history of industrial revolutions, and we have also covered the various technologies. So already one of ma'am was saying, Ramandeep ma'am, now are you able to unmute? You want to add something? Dr. Ramandeep Gautam, if you are able to unmute, you can give your views. So, like Nithya madam has said that they have done some projects related to AI. Any other participant, any other teacher, faculty who is already working in some of the technologies of Industry 4.0? So, you may share with us. Yes, anybody? So, if there are no queries, let us go back to the presentation. So, dear participants, we have already covered the what is Industry 4.0. Now, where does the industrial metaverse stands? Now, this part, this photograph, I had already shown you the history of this Industry 1, which was mechanization, mass production in 2, automation in 3, and Industry 4, we have these cyber physical systems. In 2010 onwards, we are having this Industrial 4.0. Now please see here, today, now this is the place that is the industrial metaverse and virtualization. It has been said that the industry 4.0 will now be taken place by the industrial metaverse. Already sir might have told you about metaverse, and these are the technologies, or we can say for this industrial metaverse, these are the building blocks. So it is a part, industry 4.0 is now merging into the industrial metaverse, and these are the building blocks for industry 4.0, and these have been divided into different heads. If you take the cognitive part, then in this we will be seeing that the parts which are technologies which are there are big data analytics, advanced analytics, cognitive self learning systems, then autonomous transport systems, automatically the transportation will be taking place. In the connected world, in the second block, which we call as the connected things, we have these connected things to internet, then connection or collaborative smart machines and robots, then we will have these smart energy systems. In the virtual part, already we have understood this augmented reality, then cyber physical systems and virtualized networks, virtual modeling and simulation. And the building block, which is human centered, will be considering the collective intelligence, crowdsourcing, virtual workplaces. We will have workplace 4.0, which will be known as workplace 4.0. Then we will have massive e-learning, and which we call as massive open online courses, MOOCs. That means a lot of self learning, lot of e-learning will be there during this metaverse. And in the last block, that is value added, we will have blockchain, additive manufacturing, and 3D printing, which we have already covered. And we will have integrated ecosystems, that is decentralized, mobile, value added, integrated ecosystems. So, dear participants, these are the industry 4.0 building blocks, and I will not go much in detail in metaverse because already sir might have covered it. But from this point of view, industrial point of view, we can say that metaverse is the next generation of internet based applications and social forms using the various cutting edge technologies. Some of these technologies are virtual reality, augmented reality, then 3D holographic avatars, then video games are already there, then cloud computing. Now, it is also defined as a virtual parallel life, a digital twin of real life, utilizing physical, augmented, and virtual reality to provide a metaphor of real life for its avatars in a shared virtual environment through the internet. The metaverse is basically a virtual world that allows us or the users to interact with each other or objects in real time using their avatars by breaking down all real world physical obstacles. It has been applied to various domains such as video games, art, retail, education, healthcare, manufacturing, social, and many more. Now, we have already, sir might have already covered you metaverse, but here we are talking about industry 4.0. So, what is actually industrial metaverse? Metaverse is all clear to all of you, but what do you understand by industrial metaverse? So, industrial metaverse is defined as a connected whole system digital twin with functionalities to interact with the real system in its environment, allowing decision makers to better understand the past and forecast the future. So, a very important aspect of industrial metaverse is the digital twin. So, I will show you and explain you more about this digital twin. Some of the definitions given by some of these major giants related to industrial metaverse have their own definitions. Like Siemens, they call this industrial metaverse as a virtual world in which we can interact in real time with photorealistic physics based digital twins of our real world. We believe digital twins are the building block for the metaverse. So, for the metaverse, digital twins are very important. Similarly, in the industry also, this digital twin is there. Basically, participants, a very simple word when we try to understand this digital twin, a very simple word for this is simulation. A very simple word is the models, the 3D models which we used to have in the olden days, the simulations which we used to have. Now they have been now converted into a digital twin. Another definition given is it enables industrial metaverse, enables industrial companies of all sizes to create a closed loop digital twin with the real time performance data, which is ideal for running simulations and AI accelerated processes for advanced applications such as autonomous factories that rely on intelligent sensors and connected devices. So a real-time persistent simulation space. So basically it is a space, it is a new virtual world which is taking data, which is taking inputs from the real worlds. Based upon the previous data which it has, it will give you some uh, outputs from it. So these are some of the definitions which are given by different giants, industrial giants, Microsoft and others. So in their own views regarding to the industrial metaverse. So, what are the components of industrial metaverse, or what is actually happening in this metaverse? Please see here. This is your industrial metaverse, and this is your real world. What you can understand here. This is your real life at the bottom, where it is written real world industrial system. This is actually the real. Let us take an example of an industry or a machine. Here, this is the real machine which is working from the real machine. If you see here, data will be taken from the real machine, and through connections this data will be given to the industrial metaverse. Here at the top you have the twin of that whole system, digital twin. At the top you have a digital twin. This is the actual industry, and this is the digital twin of that industry or that machine. You will take the real data, and through connections you will take this data to the digital twin, where it will be computed and it will be conceived, and by collaboration of the real data inside this digital twin, some actions will be produced, and these actions will now be given to the real world. This is how the industrial metaverse will be taking place. So hope you have understood. This is what is actually happening in the industrial metaverse. We are connecting it, we are computing, and we are conceiving, and then through collaboration we are obtaining the actions, obtaining the data. Input is from the real world, given to the digital twin. This digital twin will process it, and based upon the data it have, it will give its output to the real world. This is how side by side both the digital twin and the real world will work. So what is actually this digital twin? So this digital twin is an exact replica of the real world. So anything from a machine to a building or even a city that has been created digitally. So in order to understand this, I have taken this small video. In order to understand this digital twin, there is a small video I will show you here. The plans. So what actually we do, the plans or drawings are the three major points of this are the plans. Drawings are the foundations of the physical item in a virtual space. Sensors collect data from that thing, and they sync it with the digital model to create a real-time replica. Like I showed you previously, from the real world, it will take the, if you see here, from the real world, it will take collect the data, then it will give or sync that data to this upper part, the digital twin, and based upon that it will sync with this, and it will create a real time replica. So in order to understand this digital twin, I will show you one video, and after that we will see the various applications of this industrial metaverse. What are the major applications where this industrial metaverse is being used? So first of all, a brief 2 minutes video of, in order to understand what is this digital twin. Let me show. Now let us understand some of the advantages and disadvantages of Industry 4.0. The advantage, see, one major thing I have already covered before, that if you do not go along with the technology, you will be left behind. Whatever new technology is coming, We need to adopt as a country or as individuals, we need to adopt the new technology, otherwise we will be left behind. So the advantages of industry 4.0 is that the productivity is fast, more flexibility is there, more profits can be gained, and you have a better customer experience. You can work more safely when you are working with machines. Then optimization is there and customization is there, like in 3D printing and all we saw, that you can customize the products according to the requirements by using industry 4.0. And this is one case study, and there is a video also of this, okay, how now industry 4.0 is providing solutions in various industries. Now here there is a new generation of a safer, more user friendly robots which work more closely along with human. That means now see what actually happened. Okay, initially when there was robot assembly, then they were afraid, okay, now robots are working in the, if you see in the first picture only robots are working, in the second picture only the humans are working. But now by industry 4.0, both of them have been integrated in one. The heavy part, the work which is heavy or which requires lot of force or energy, that is done by the robots, and the simple part like screwing of nuts and all, that is done by human beings. So this is a wonderful case study of how industry 4.0 is making the work faster, safer, and more user friendly robots alongside with the humans. Now, apart from whenever there is new technology, when these industrial revolutions, previous industrial revolutions also came, revolution 1, 2, and other revolutions, apart from advantages, there are always certain challenges of industry 4.0 or any other new technology when we are talking about metaverse also. So these are some of the challenges of this industry 4.0 are the economic, there are economic challenges, social, technical, organizational, based upon employment and on some political also. And the major challenge in which we all are facing is the cybersecurity. Now since the factories machines they are going to be controlled online, the hacking of the server can make it a huge loss, especially when we are talking about metaverse. In metaverse, if you see in the digital twin, what we were doing, we were taking the entire data from the real world and we were transferring it to a machine. That means the actual data has been taken from there and has been transferred to a twin of that machine. That means there are a lot and lot of cybersecurity issues related to that. That means that if the data is hacked, the entire work will be hacked. So second major question or problem in this is the skilled workers. I have a very good video where I will show you after this at the end of the session, where we have industry 4.0, but they are saying that you are saying so much technologies have come, metaverse has come, avatars we are using, but who will do this work? From where will the skilled workers be coming for that? So as the technology is advancing, the skills and education of workers working on industry 4.0 based processes need to be improved drastically. Then corporate IT department will become redundant. Now already you must be aware, with a little bit of more automation, when this chat gpt has come, now already the computer people are saying where will be the programmers go? If the chat gpt is making the programs, previously we as human beings were making the programs, so who will what will happen to the programmers, human people? So corporate IT departments will become redundant. Already we are talking that so many industries they are reducing their employees, they are reducing their workforce. So what will people do if everything becomes automatic? We are talking about metaverse. The teachers will not be there. Our avatars will be teaching in the classes, avatars. So what will happen to the other people when we are adopting so much technology? This is a major threat to IT people today. Maximum major force which in our country also they are actually using, we are doing lot of programming and a lot of people are in IT sector. Where will they go? So they will try to block everything. Then social issues I have not considered here, but I had prepared one presentation where when these previous industrial revolutions came, when industrial revolution 1 came or 2 came, then also there were a lot of social issues. For example, previously people were living in rural areas in but when these industries came, they started mushrooming towards the industrialized cities. what happened, these slum areas, they mushroomed, a lot of problems came. Initially they were working in villages, they were earning little, eating healthy food, but now they came to cities. So lot of, whenever there is some technology change, then a lot of challenges related to the social issues, social well-being of the people is also there. So a lot of study in the previous years has also been done. Okay, with the industrialization, what are the social problems we will created? So when this new metaverse and industry 4.0 we are talking about, a lot of social issues will also come. Already we are facing some issues like people are not social enough, they are already working on phones, they are chatting on phones. And even our kids, they do not know how to meet new people, how to communicate with people, though they know very well versed with communication on the internet, on the WhatsApp, on through mails, but socially how to interact, physically how to interact, they do not know. So there was lot of urbanization and industrialization, and we don't know how the things will shape up now. Then the capital cost, always whenever new technology is come, is been taken care of, so the capital cost is there. So the industries which are working on industry 3.0, now we are asking them to convert to industry 4.0, that means capital cost will be involved. But when we are talking about metaverse, then again some capital cost will be involved in that. So again a lot of changes regarding to the capital cost will be required. Then, under technical challenges, there is a general reluctance to change. Whenever a small change comes in any industry or in any organization, so the top management or all level of managements, they have many technical problems. So the company management, since when internet comes, transparency is the key issue. Already when some things are done online, many things are being done online. So when online we are doing things, that there is more transparency, so this is again another pillar. So proactive maintenance to reduce costly production is expensive, reliability and stability is required. This demands very short and stable timings in the system. Other technical challenges involve integrity of production processes. Machines by themselves, they have their own limitations. They cannot perform complicated or non-repetitive tasks. Sometimes that is not to be done. See, sometimes how the work machines are working through artificial intelligence. We are giving them some previous data. Based upon that, they are making decisions. But something new occurs. Suppose there is a factory, and some machine catches fire. So does the machine, if a worker is standing there, the worker will switch off the machine, and he will tell the other workers to come outside or use some mechanism to extinguish the fire. But does the machine know, okay, now I have to stop, the fire is there or smoke is coming? So these types of things, can we independently leave the machines 100% on their own risk to for the work to be accomplished? Again there is a question mark, and a technical challenge involved in this. So dear participants, this is a slide I which mostly show, okay, already many things were not existing in year 2006. The technology is moving very fast. So if we do not go along with the technology, we will be left behind. And this is the time to reach 100, this is the time taken to reach 100 million customers. So this is already what we are doing, and this has been already developed. In the last, I will show you a small video of industry 4.0 and what are the challenges which we will face in industry 4.0. So dear participants, this is all